Hi everyone. In the previous video I said that I'll show you guys how to make a simple Tazer using this circuit. In that video I explained how this circuit works and how it is able to create an oscillating magnetic field. Here this circuit will be used to drive a transformer. So if you want you can check out that video by clicking right here. To make this Tazer circuit we will also need a few additional components which will be very easy to find, and I will also tell you where you can find them very easily. Let's take a look at the circuit diagram first. This is the complete circuit diagram with all the details. First we have the 3.7 volt battery. Next we have the transistor and resistor which are connected to the primary and feedback coils of our transformer. We will wind the coils of the transformer ourselves. The transformer has 15 turns in the primary and 15 in the feedback coil, whereas the secondary has around 150 turns. Since the transformer has a large number of turns in the secondary coil, it will increase the voltage from our primary from 3.7 volts to several hundred volts in the secondary. At the output of the secondary we have a diode, after which there is a high voltage capacitor which will store the high voltage to make it more powerful. And as you can see, this is pretty easy to understand and requires very few components. Also, some of you might be wondering what are these dots here for. These dots represent the starting point of a coil in an inductor or a transformer. Basically they help us understand the flow of current in the coils, assuming all the coils in the inductor or transformer are wound in the same direction. So if the direction of current in one coil is like this, then the induced current in the second coil will have this direction. Now let's start making this Tazer circuit. For that you will need this, a small transformer which you can easily find in small switch mode power supplies or power adapters. We have to remove all of its coils so that we can wind new coils in it. Of course you can use the original coils from some of these, but most of the time it is very hard to figure out the correct orientation of the coils without disassembling the transformer. So it is better to just wind new coils. Let's disassemble the transformer first. After removing this tape, we can see that the cores of the transformer are glued together. To remove them, we heat them using our soldering iron, and once the glue heats up, it becomes soft. Now we can remove the cores very easily. An important thing to notice is the air gap between the cores of the transformer, which is common for flyback type power supplies. Make sure the transformer you are using has this air gap between its cores, as it is necessary for our circuit to work properly. Then we keep removing all the insulation and windings till we get the bare skeleton of the transformer. Remove any leftover glue or any other residue from it, and now we can wind new coils in it. For making the coils, I am using 0.4mm enameled copper wire. You can also use thinner one, but since this transformer is not that small, I am using this size. First we will wind the secondary coil. For that we have to make around 150 turns. Make sure to remember the winding direction, as both the secondary and primary coils must have the same winding direction. After 150 turns are completed, secure the ends of the wire so that it doesn't unravel. Then take some electrical tape and cut it to size to cover our secondary coil. This is for insulation between the secondary and primary coils, as the secondary coil will have a higher voltage. For the primary and feedback coil, take 2 lengths of enameled copper wire and wind 15 turns in the same direction as the secondary coil. Then remove the insulation from all of the ends and tin them using your soldering iron. After that we add the cores back and use some zip ties to hold them in place. Next, let's work on separating the primary and feedback coil. For that, we use the multimeter on continuity mode and use it to find out which two ends are connected together. So this one is connected to this one and this one is connected to this one. Connect the end point of any coil to the starting point of the second one. Now basically what we have here is a center tapped coil. We will use this side as the primary coil and this side as the feedback coil. For convenience, I connected the coil ends to the pins on the transformer body. These are the secondary output and this is the center tap. And these are the primary and secondary ends. Now we can connect our transistor and resistor. For the transistor, I am using the same BD139, which is a NPN transistor. You can use any other similar NPN transistor that you have laying around. The collector of the transistor goes to the end of the primary coil. The value of the resistor I am going to use is 220 ohms. One end of the resistor goes to the feedback coil and the other end goes to the base of the transistor. Add power wires to the center tap and the emitter of the transistor. Next, add a diode to the starting end of the secondary in this orientation. It is better to use fast diodes such as this FR207 or UF4007 as the circuit is switching at a very high frequency. You can find fast diodes on the ballast of old CFL lamps or in the power supply section of some circuit boards. But I tested this circuit with the common 1N4007 diode as well, and it works well with that too. So if you have that, you can use that one too. After the diode, we add our high voltage capacitor. This one is rated for 2000 volts. If you don't have a high voltage capacitor, you can connect multiple capacitors like these in series. In series, their capacitance will decrease, but now these can handle up to 1600 volts. Therefore, these will also work. And now our Tazer circuit is complete. So let's test it. Okay, now let's measure the output voltage. The meter is showing around 400 volts. But when I disconnect the meter and touch it again, it shows a higher voltage. Then it settles back down to around 400 volts. What is happening here now is that the multimeter is loading the output, and since our circuit is not that powerful, the output voltage collapses and we are getting a lower voltage when measuring. Even the sparks are weaker when the multimeter is connected. But still, this is a very high voltage, and without the multimeter, the voltage goes even higher. So this is the complete Tazer circuit. Very easy to make and not that powerful. So you are not going to seriously hurt anyone or yourself with this. What you can do is put it in a box and add a safety switch and a push button. Also, you can add some prongs on the output just like a real Tazer. But this one won't work over clothes. For that, the output must be around 10,000 volts or higher. And the output of this one is around 800 volts, so it needs direct skin contact to shock someone. Now let's test it with these. As you can see, it is working just like before, maybe a bit weak because of the low capacitance. So now you can make this yourself and shock people you don't like. So this was all for today. If you liked this video, then please give it a thumbs up and subscribe to the channel for more videos like this. Next video would be about how this transformer is generating such a high voltage, and it would be very interesting as well. So stay tuned for next video, and once again thanks for watching.